Welcome to the Bowser Dilemma. Today's class we're going to be talking about chapters 3 and 4. A couple reminders. Make sure you've watched the one sample t-test class before. That's going to be very helpful. And let's do it. Let's talk about this idea of how to run a test, right? The first thing we do when we're running a test is that we make a statement about the population, right? We write the null hypothesis. So the null hypothesis right here is the average difference in depression between Instagram users and no Instagram users is 0. Okay, cool. The second thing we do is establish a criterion to decide if that null hypothesis is false, right? Which usually are the critical values. So we're going to establish a 95% criterion for this null hypothesis, giving the null hypothesis enough wiggle room, right? So we make sure that maybe, we're living in a world 0. Let's give it enough wiggle room for this world 0 to have some random error. And third, we're going to get a sample from the population about that statement. So here's our distribution. We already know it's there. We're going to go get an average from a sample. Let's see if the test statistic, if the main number that we're testing here is an average in the sample. And we plug that in there and we ask ourselves, hey, is this average within the 95% confidence interval or not? And if it's in there, we'll retain the null hypothesis. If it's outside, we reject it. Fourth, a probability. So we're looking for a probability that this sample is coming from world 0, that this sample is coming from a world in which the null hypothesis is true. The thing we're trying to make sure of is not that our theory is correct, but rather than the opposing theory is incorrect, right? Or is unlikely. So look, here we plugged the average in the sample. This is our H0 distribution. In this area that you find here is the likelihood that if we were living in an H0 world, if we're living in a world where the null hypothesis is true, we would draw a sample of a value equivalent to the average that we found or higher. A bunch of words just to say, hey, this is the chance that our sample is coming from world 0. And that's going to be given to you and the p-value, right? So we have the p-value here, p equals 0.20, which means that there's a 20% chance that we would have found a sample of this value or higher if the null hypothesis were true. Roughly, if you don't want to think too much, you just think to yourself, hey man, it's like this is the chance. There's a 20% chance that this sample is coming from a world 0, right? From a world in which the null hypothesis is true. Cool. Let's look at this null hypothesis. The average difference in depression between Instagram and no Instagram is 0, right? So this is the null hypothesis, and I just want to establish a difference between the null hypothesis and the nil hypothesis. The nil hypothesis is the hypothesis that includes 0. And I'm saying that because we always actually include 0 in every single null hypothesis that we have. And that's what we have to do because that's what most of the software that we use. So we always have a nil hypothesis. In this course, we always write a null hypothesis with a 0.